program I used for this demo that when you push the button once, it will flash the LEDs once, and if you push the button second time, it will flash LED twice, and if you push the third time, it will flash 3 times, and so on. And when you get to more than 10, the green LED will indicate 2 decimal digits, and which I don't think that we're going to get that far. So let's look at the code itself. The code has 2 parts of it. One part is the main program. Main program has a few components here. One is that this is the main program. That's all the programs are. Okay? And what in the main program is start with is stop the watchdog timer, just like we have been doing all the time. And then we set the directions of the red and the green LED. In the meantime, that if the bit is not set, that means it's coming inside. So the button which is on bit 3 will become coming in. So LEDs and greens, red and greens, and the buttons are defined as it's pound defined. So pound defined LED is bit 0, green is bit 6, and the key is bit 3. The button is bit 3. Yeah. We also have global variables, which is that the count here. And what it's going to be is that we will use the count to count how many times we hit the keys. So inside, this is going to be used in the interrupt service routine. Every time when the interrupt service routine is executed, that means that there is a key interrupt coming in. The count will get incremented. So we just keep counting how many times we hit the keys here. And then we can use that to flash how many times the LED is going to flash. Okay. So after we initialize the port 1 and we turn off the LEDs, and the direction is set, LED is off, and then we will deal with the buttons. The buttons are a few things we have to do the initializations. One is the button has a pull-up resistors we have to do, and if you're not quite familiar with what the pull-up resistors, ask them in the discussion group. We discussed it once, but we can go over it again. The second one is that we have to decide which edge we want him to generate interrupt. Is it high to low or low to high? And because we're using the pull-up resistors, that means if there's nothing get hit there, it's going to be 1. So when the thing get hit in the key get pressed, it's going to become 0. So it's high to low. We want that thing to be generating the interrupt. Okay. So the interrupt edge select, IES, is edge select. Edge select register is set up to go from high to low to generate an interrupt. And when you generate the interrupt, it's going to show up in the interrupt flag, IFG, in that IFG registers. Except that in this particular instruction here, we want to clear that IFG registers such that we start with a clean slate. There is no residue effect from previous sessions or whatever the situation is. We want to just clean out. So it's really initialization to clear out the interrupt flag so that we start with clean. So that one, we clear out the key, the buttons interrupt flag. Then we enable the interrupt for the key by turning on the IE, interrupt enable register, IE, interrupt enable register. Okay? And to turn on the particular bit. Inside the IE, interrupt enable, there could be 8 possibilities, but all we are interested in is turn on the button 3. After we did all that initialization of the buttons, okay, what I'm doing here is really just flashing the red light twice so that at least I know the board is still working correctly. Then afterwards, we turn on the CPU's interrupt, and everything is ready to go. Just sitting and waiting for interrupt to come. And when interrupt comes, it's going to come through the interrupt service routines, which is what we are doing here in these sections. Okay? In this section, it's when this is get executed, that means when somebody push the button and interrupt generated to the CPU, and CPU will come to this routine. And in this routine, what we can do is really we check to see if it's indeed coming from the key. If it's not coming from the key, we do nothing. But if it's coming from the key, we do all this. Now, if you know there's only one way you're going to generate interrupt, then you can ignore these guys. You can ignore the check. But it's always a good idea to make sure that what you are processing is indeed the interrupt is coming from the key. An interrupt coming from the key is checking it by looking at interrupt flag and end with the key to see if the key is indeed 1. Okay? So of course you can say that it is equal to the key or not. Okay? And if we do get the key interrupt, what we did is increment the count, and then we go blink the lights. And to blink the lights, you blink the red lights for first time we hit it, blink the red light once. Second time we hit it, blink the red light twice, because we're using the count, and we count using a for loop to count from 1 to whatever the count is, and divided by residue of 10. Okay, when you go beyond 10, we will blink the green, but if you hit them many times, you go to the green. Then after we blinking the lights, we clear out the interrupt flag, so it's ready for the next interrupt to come in. All right, so that's the whole program. And in here, all this green or red blink is all done in a different files, and that file is miscellaneous.c. Okay, miscellaneous.c has the delay loop. Okay, so delay how many milliseconds on your flashing, and in the blink, you set up the direction and you go to that, turn it on, delay 100, whatever the thing is, it's a millisecond, it delay 1 second, and then turn it off and delay 1 second. So turn on, wait 1 second, turn it off, wait another second. So that's what the red LED blink. You might notice that if we already set up the P1 dir in the previous initialization, we don't really need this. Okay? We don't really need the P1 dir here because the P1 dir didn't get changed. So it's just one of those things that do you want to have your routine to be self-contained? And if this routine is self-contained, then I better set the P1 dir so that even if other people screw me up, I can still do my job here. So treat it as a safeguard to your routines. The same thing holds true for the green blink, and I leave it for you to go through it yourself. And again, on this one, we didn't using the bit 0 or bit 6, just to show you that there are different ways of doing exactly the same thing here. And you can compare to see what style you like. Okay. All right, so let's run it. Oh, okay, one more thing. Because those routines, we are using it in the main routine is in a different file, we need to tell the compiler, okay, what those 3 routines are. And so this is how we tell them. We tell the compiler we're using the red blink routine, we're using a green blink routine. I don't think we use the delay MS routines here, so that one can be deleted without any problem. Okay, you can just comment out these 2 lines, but we do use these 2, so this has to be there. Otherwise, compiler will tell you that you cannot find the red blink link and you cannot find the green blink either. But you can get rid of the delay millisecond. It's no impact. All right, so let's run it. Okay. I do have the board connected to it, and by running through it, okay, I think you can go through the single steps, which to do what we have been doing before. This is initializations, and then go through that the different the buttons initialization, and again you can go to the registers and look at the P1 port 1, 2 and have all the different registers. You can pull it down if you want to see more, okay, but just that's enough. Most of the stuff you'll be using will be on this side, and keep going down with a different P1 enable, IE enable, and you will see that thing would become enabled, and you go right. So you blink the stuff twice, okay? Let me go back one more time just to show you that all the things that the P1 REN, P1 IES, they will be all show up on the side. So you do single step through each one of these instructions, you should be able to see what actually it changes. Okay? Then we have to go through all of this to get into to really generate the interrupt, but we want the breakpoint to be in the interrupt service routine. So we set the breakpoint in the interrupt service routine such that whenever the interrupt comes, it will hit the breakpoint. Then we can stop to see what are the things going on there. So in order for that thing to hit, we need to get the board to run, and the board to run by hitting the go button. So the board is running now, and if I hit the buttons, it should stop. It should go to the breakpoint. All right, so here we go. I hit a button. Okay, so indeed it stopped right there. So this is only when you hit the button and the button generates an interrupt, the P1 generates interrupt to the CPU, and the CPU goes to the P1's interrupt routine, which is right here, and he will stop right there. And when it stops, you check to see P1 IFG with the key, just like we said before. Look at the P1 IFG, it's 09. 09 has 2 bits, it's bit 3 and the bit 1. And bit 1 happens to be the red LED. So both red LED also is setting up the IFGs. But we are not really enabling that guy, so we don't really care about him. All we care about is a bit 3, which is the other flag in there is working or not, and we have it. So we were supposed to go to the next guy, okay, then to increment the count. All right. So where is the count? How do we know where the count is? So you can look at the count by get that one to be count equal to 0 at the moment, okay? Or the other way to do it is you can go to the expression and just add a count in there. So that's what I would do, okay? You add a count, and that the count currently is 0. And then next instruction is going to working over, it's going to increment the count. Or you can also, by looking at the count, will become 1. So either way. So now we're going to do because count is 1, we're going to blink that many times in the red. So that's after we do that, and you end up with going to be is to clear up the flag, interrupt flag. So let's see. Step over one more time. One more time. That's the red blink. Okay, and we blink the red. Okay, and okay. So once we blink the red 1 time, we're going to clear out the P1 IFG. If we look at that guy, the P1 IFG right now is still 09 because since we coming into the interrupt service routine, it never get changed. So now we need to do is we need to clear out that flag, which is coming from the button. We push the button, it generates that bit 3, and we have to clear it so that we are ready for the next guys coming in. Okay, we clear that. The bit 0, we don't really worry about it. So now we can let it go. Look, if I don't let the machine to go, we're not going to get another interrupt. But let me just go hit it. Okay, let it go, and you hit another interrupt. It had another key, it comes in again, and the whole thing goes repeated. And I let it go, it will flash twice, and I hit it again, it will flash 3 times, and so on. Okay, so that's about the exercises you're going to do.